Hi, today we're going to talk about section 3.2. In this section we'll be talking about graphing the tangent function. So we're going to start with an information dump similar to what we did when we talked about the graphs of sine and cosine. So the similar table that we'll build here for tangent is the similar table that we built for sine and cosine. So we have the function that we're talking about: domain, range, symmetry, continuity, midline, period, frequency. You'll notice that amplitude is missing from this list. We'll talk about why that is, but graphs of tangent don't have any amplitude. So let's first talk about domain. So remember that tangent we defined as opposite over adjacent in a right triangle situation. And you'll remember in the unit circle situation we defined it as y over x. And in the unit circle, y was the same as sine. Oops, well, maybe we should call that theta. And x was the same as cosine. So really what we're talking about here, tangent, is going to be defined as sine over cosine. If we think back to the unit circle, so again, tangent was sine over cosine. If we go to the unit circle and look at this then, so for example at 0 radians, my value for sine is 0, and my value for cosine is 1. But if we move to pi over 2, my value for sine is 1, and my value for cosine is 0, which makes tangent undefined. So here, tangent is going to have vertical asymptotes because we have places where the output for tangent is going to be something over 0. That's going to occur everywhere where the x-coordinate on the unit circle is 0. So it's going to happen at pi over 2. It's going to happen at 3 pi over 2. It would happen again at 5 pi over 2. And at 7 pi over 2, and every pi units from there, right? So 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, all throughout. So the way that we're going to describe that, since there's infinitely many of these holes in our domain, these vertical asymptotes, the places where the function is undefined, we're going to write it in the following. So we're going to go back to this x is not equal to, and we're going to do n times pi over 2, where n is an odd integer. So again, our odd integers like 1, 3, 5, 7, that would be pi over 2, 3 pi over 2, 7 pi over 2, 5 pi over 2, and the negatives along with it, right? Okay. Now let's think about the range here. Remember that tangent is sine over cosine, so y over x. So take, for example, this point like right here on the unit circle, where x is really, really close to 0, like 0.00001, and the y-coordinate is very close to 1, say 0.99999. So the closer that x-coordinate gets to 0, the bigger the value of that fraction is, right? So if you think about that, you know, like if I have 1 divided by 1, that's 1. But if I have 1 divided by 0.5, that's bigger. If I have 1 divided by 0.1, that's bigger yet. If I have 1 divided by 0.001, bigger yet. So the closer that denominator is getting to 0, the bigger that fraction is going to be. So this, as we're getting closer and closer and closer to pi over 2, my y-coordinate is going to positive infinity. Likewise, the closer we get to 3 pi over 2. We're going to be getting closer to -1 over something close to 0. So we're going to negative infinity. So that's going to be my range. So here, my range is all real numbers. So let's go ahead and draw our graph now, what this is going to look like. So at when the angle is 0 radians, we're going to have 0 over 1. So that's 0. So we'd have 0, 0. Here's my graph of tangent. At pi over 4, we're going to be at root 2 over 2 divided by root 2 over 2, which is 1. At pi over 2, we're going to be at 1 over 0. So there's going to be an asymptote. At 3 pi over 4, we're going to have root 2 over 2 over negative root 2 over 2. So that's -1. So down here, at pi, we're going to be 0 over -1, which is 0. At 5 pi over 4, we're going to have negative root 2 over 2 divided by negative root 2 over 2, which is +1. And then at 3 pi over 2, we're going to have -1 over 0, so undefined again. So that's my asymptote. And it'll just kind of continue on like that. Again, I would never ask you to generate the graph from the unit circle, but that's kind of what we're doing. So that's where we're getting our shape from. If you look at this shape, notice that these two quadrants look like they're reflections of each other. That was indicative of odd symmetry. The continuity, we would say, instead of continuous everywhere, we'll say we're continuous over the domain. So as long as we back out the places where we have these asymptotes, we're continuous everywhere in between our asymptotes, is basically what we're saying. So notice that if we look at the graph of tangent here, there is no extreme points, right? There's no maxima or minima on this because the ends of our graph are pointing up and down, going on forever. So there can't be any amplitude because there's no maxima or minima. But we still have our midline here that's going to divide this graph in half. That's still at y equals 0. Notice our period, though, if I look from this asymptote to this asymptote, is basically one non-repeating section. Every one of these asymptote sections is a repeat. Notice there we're going from 0.5 to 1.5. So our period is just pi units. Note that is different than sine and cosine, whose period is 2 pi. And then as a result, our frequency is going to be obviously the reciprocal. So let's talk about what's going to happen for the transformation of tangent. So the domain here is going to change, right? So what's going to change the domain? Will a vertical stretch change it? No, right? Pulling up and down isn't going to change where those asymptotes are, because those asymptotes, if you pull it up and down, the asymptotes don't change direction. A vertical shift isn't going to change the domain. What will change the domain is H and C. So moving the graph left and right can change the domain, as well as stretching it or shrinking it horizontally. So if we remember, the C is multiplicative, and the H is additive. I really should say absolute value of C, because if you remember, C can be positive or negative. Again, where n is an odd integer. Again, that Z symbol is just our symbol for integers. If the domain or the range was all real numbers before, nothing we can do can change that. Again, most transformations can just destroy any symmetry we might have. So we're not going to worry about that. Again, if it was continuous over the domain before, nothing we can do can change that. The midline is going to just be y equals k. The period, again, can be changed by C, just like before. And then the frequency is obviously the reciprocal of that. Okay, let's look at a couple of examples. Actually, before we do the examples, we should probably talk about the key points. So if we're going to go from the equation to the graph for tangent, our key points that we're going to use are as follows. So we have negative pi over 2 undefined, negative pi over 4, negative 1, 0, 0, pi over 4 positive 1, and then pi over 2 undefined again. Again, these are things I wouldn't expect you to memorize. They'll be things I would provide to you on a test or a quiz or whatever, so don't worry about that. Okay, so let's try to graph something. Let's say we want to graph the following. So let's say we're going to graph negative 3 times tangent of x over 2 plus 8 minus 1. So the first thing I'd want to do is identify my values for A, C, H, and K. To do that, I would start by writing this in our standard form for a transformation. So I'd factor the 1/2 out. From inside my tangent function. So my A is negative 3, my C is 2, my H is negative pi over 4, and my K is negative 1. So I'm going to take my key points. Maybe let's write down our transformation first, right? Just so we make sure that everybody's on the same page with what we're doing. Let's write that down. Okay. Again, that's the same transformation that we've used before. Cx plus h, ay plus k. So now we're going to take our 5 key points. And perform our transformation on them. Now, one of the nice things about tangent is that undefined, no matter what you do to it, stays undefined. So I know that the y-coordinate for the first point and the last point is just going to be undefined, no matter what we do. So I only really have to worry about changing the x. So if I plug in negative pi over 2, 2 times negative pi over 2 is negative pi, and then minus pi pi over 4 there is going to be minus 5 pi over 4. Plugging in negative pi over 4, 2 times negative pi over 4 is negative a half, minus a quarter is a 3/4, and negative 1 times negative 3 is positive 3, minus 1 is 2. And then plugging 0 in, I just have h and k. And then plugging 1/4 in, 2 times 1/4 is 1/2, minus a 4th is 1/4. Negative 3 times 1 is negative 3, minus 1 is negative 4. And then lastly, uh, 2 times pi over 2 is pi, minus a quarter is 3/4. So those are my points. So the last thing I would do is to plot these. So I think on the homeworks I gave you, you have a grid much like you've had before. I don't have one of those handy to drop in here, so I'm just going to plot my own stuff. So I'm just going to go by quarters of pi. So 1/4, 2/4, 3/4, 4/4, 5/4, and 6/4, 7/4, 8/4, so that's negative 2 pi, and 1, 2, 3, 4, 5, 6, 7, 8, that's positive 2 pi, and we got to go up to 2 and down to 4. So I like to start by putting my asymptotes in. So at negative 5, 2, 3, 4, 5. There's my asymptote. And there's another one at positive 3. Those are my asymptotes. Okay. And then I have negative 3 pi over 4 and positive 2. Negative pi over 4 and negative 1. And then I have positive pi over 4 and negative 4. So my graph kind of comes through like this. And then I want to fill my space out. So here, right next to that, should be at negative 4. And then over here, we should be at negative 1. I don't care about the rest of it. You can draw the rest if you want, or you don't need to. Over here, I should be at positive 2. And then 2 more from there, I should be down at negative 1. And that's all I have to draw there. So there's my graph. Everybody okay with that? Okay. Next example. Let's say we want to go from the graph to an equation. So this will be very similar to what we've done already for sines and cosines. Okay. So the nice part is there's only one equation that I can write. So I'm just trying to do this. Okay. So my first order of business is to identify my midline, which is right here, which tells me then that k is equal to negative 1. My a value is going to be to these points, back to the midline. So that is going to tell me that my a is 1, going from negative 1 to 0. And because I noticed that the graph of tangent, when I graphed the parent function way up here, goes from down to up as we move left to right. And in our example here, we're also going down to up. Oops. That tells me that that A is positive. If it were reversed, if it was up, down, it would tell me the A is negative. The next thing I'm going to do is look at my period. So my period, I like to go from asymptote to asymptote. So that's negative pi over 4 to positive pi over 4. So that tells me that my period was pi over 2. And I know that pi times c is equal to 1 period. Remember, the period is different for tangent than from sine and cosine. It's not 2 pi, it's just 1 pi. So I multiply both sides by 1 over pi to get the c by itself. It's 1/2, and like before, we'll always assume the c to be positive. Okay, with that. And then the last thing we'll do is find our h. So I'll take my midline point from tangent because its x-coordinate is 0. And remember, this was down and midline point up. We've already observed that part already. And we're going to this midline point. Again, in the transformed version, we have the same type. So again, we observed this part already when we said that A was positive. And since our x-coordinate in the parent function is 0, then our x-coordinate in the transformed function is our h. And just like before, we are done. So this one is y equals 1 times tangent of 1 over 1/2, or you could just write a 2 there. X minus 0, you could just write x there, minus 1. And they're all basically like this. Again, really, really similar to what we did with the sine and cosine functions. And that's it for today. Good luck with the homework, and I'll see you next class. P.S. Watch out for a homework quiz.